My name is Captain Cosmic, and thank you for watching. NASA telescopes discover record-breaking black hole. Astronomers have detected the farthest black hole ever observed in X-rays using NASA telescopes, and it made me shake in my space boots. The black hole is in an early growth stage that had never been witnessed before. With a mass similar to that of its host galaxy, my space boots had to come off. This finding could potentially explain the formation of some of the earliest supermassive black holes in the universe. Combining data from NASA's Chandra X-ray Observatory and NASA's James Webb Space Telescope, researchers identified the characteristic signature of a growing black hole just 470 million years after the Big Bang. Astronomers discovered the most distant X-ray emitting black hole in a galaxy known as UHZ-1 using the Chandra and Webb Space Telescopes. X-ray emission is a distinctive sign of a developing supermassive black hole. This result could clarify the origins of some of the first supermassive black holes in the universe. These images depict the galaxy cluster Abell 2744 behind which UHZ-1 is located. And the subscribe and like buttons are under your fingers, so please subscribe and let me know if you like this video. That, along with close-up views of the black hole's host galaxy UHZ-1. A cosmic magnifying glass, known as gravitational lensing, amplified the amount of light we detected, said Akos Bogdan of the Center for Astrophysics. Bogdan and his team located the black hole in a galaxy called UHZ-1 in the direction of the galaxy cluster Abell 2744, situated 3.5 billion light-years from Earth. Fortunately, that black hole is far away from us, and I can put my space boots back on. However, Webb's data revealed that the galaxy is much more distant than the cluster, at 13.2 billion light-years from Earth when the universe was only 3% of its current age. Over 2 weeks of observations, Chandra confirmed the presence of intense, superheated X-ray emitting gas in this galaxy, a characteristic of a growing supermassive black hole. The light from the universe and the X-rays from the gas surrounding the supermassive black hole are magnified approximately fourfold by intervening matter in Abell 2744 due to gravitational lensing, enhancing the infrared signal detected by Webb and enabling Chandra to observe the faint X-ray source. This discovery is crucial for understanding how certain supermassive black holes can attain immense masses shortly after the Big Bang. The question arises, do they originate directly from the collapse of massive gas clouds, resulting in black holes weighing between 10,000 and 100,000 times the mass of the Sun? Or do they stem from the explosions of the first stars, creating black holes weighing only about 10 to 100 times the mass of the Sun? According to Andy Goulding of Princeton University, there are physical limitations on how fast black holes can grow once they have formed. But those born with greater mass have a head start. It's like planting a sapling, which takes less time to grow into a full-size tree than if you started with only a seed. Bogdan's team has found compelling evidence that the newly discovered black hole was born with substantial mass, estimated to be between 10 and 100 million times the mass of the Sun. Based on the brightness and energy of the X-rays, this mass range is akin to the mass of all the stars in the galaxy where it resides, a stark contrast to black holes in the centers of galaxies in the nearby universe, which typically contain only about 0.1% of the mass of their host galaxy's stars. The substantial mass of this young black hole, along with the level of X-rays it emits, and the galaxy's brightness detected by Webb, suggesting the existence of an outsized black hole formed directly from the collapse of a massive gas cloud. Natarajan said, "We believe this is the first observation of an outsized black hole, and the most compelling evidence to date is that some black holes originate from massive gas clouds. For the first time, we are witnessing a brief stage where a supermassive black hole weighs approximately as much as the stars in its galaxy before it lags behind." The researchers intend to use these and other results from Webb, along with data from various telescopes, to build a more comprehensive picture of the early universe. NASA's Hubble Space Telescope previously demonstrated how light from distant galaxies is significantly magnified by matter in the intervening galaxy cluster, providing part of the rationale for the Webb and Chandra. The Chandra X-ray Observatory, as part of NASA's great observatories, alongside the Hubble Space Telescope, the Spitzer Space Telescope, and the now-retired Compton Gamma Ray Observatory, enables scientists from across the globe to capture X-ray images of extraordinary environments. This capability contributes to our comprehension of the universe's structure and evolution. NASA's Marshall Center for the Science Mission Directorate in Washington, D.C., oversees the Chandra X-ray Observatory program, the Smithsonian Astrophysical Observatory in Cambridge, Massachusetts, responsible for the day-to-day management of flight operations and scientific activities through its Operations Control Center and Chandra X-ray Center, (C facilities. The James Webb Space Telescope stands as the world's leading space science observatory, tackling mysteries within our solar system, investigating distant planets orbiting other stars, and delving into the enigmatic structures and origins of our universe and our place in it. Thanks for watching.